Hello, Assalamu alaikum. How are you all?
Walaikum salam, ma'am.
All good? Everything's good?
Yes, alhamdulillah.
So I am going to share my screen with you guys. Let me know if it is visible. Yesterday we have completed chemical energetics. Does anyone have any questions, any queries regarding the topic? No questions, no queries?
No, ma'am.
Okay, I've shared the screen. Is it visible to everybody?
Yes.
All right. So the first question here says, let's just go through a few questions from past years and then we're going to move on to a new topic. So the question here says, which row describes the changes that take place when metals, they burn in oxygen? Write your answers in the chat box. Okay, so most of the students, they are saying C. Yes, C is the right answer. Very good. Yes, very good. That's right. This means that when the metals, they are going to burn in oxygen, the temperature must increase, right? As this is an exothermic process, and we say that the metal is going to be oxidized. Okay, whenever any substance basically it undergoes a combustion reaction or it burns in excess of air or oxygen, this means that it is undergoing oxidation reaction. So this means C is going to be the correct answer here so far. Look into the next one. When calcium carbonate is heated strongly, carbon dioxide gas is produced. Which words do you think describe the type of change that takes place? Is it A, B, C, or D? Is it endothermic, chemical or physical change, or exothermic, chemical or physical change? Yes, very good. A is the correct answer. Good. Why do you think A is the right answer here?
Because from calcium carbonate, carbon dioxide is produced and it is a chemical change and heat is being absorbed.
Heat is being absorbed. Yes. The first statement here basically says, very good, Vasu. So the first statement basically here says that calcium carbonate is heated strongly. This means that it is undergoing thermal decomposition. Yesterday we studied that thermal decomposition is a typical reaction of endothermic, right? It is a typical endothermic reaction or an endothermic process, which means you're going to simply eliminate option C and D. Then you're going to look whether this type of change is a physical change or a chemical change. A chemical change is the one where a new product is formed, new bonds they are produced. Okay. So option A is the correct answer here so far. All right. Look into the next one. A reaction pathway diagram is shown in front of you. Which statement do you think is correct for this reaction? Instead, they have given a metal and a non-metal instead of calcium carbonate. For instance, do you have particular reaction in your mind, Zoya?
No, miss, any metal and non-metal.
Like they both, metal and non-metals, they both undergo reaction?
Yes.
Okay, for instance, like you may say that iron and sulfur, they undergo reaction. Iron is a metal, sulfur is a non-metal. So in this particular case scenario, if you see, and it completely depends upon the particular reaction, okay? And if you see that a new bond or a new compound is not formed, okay, it is a mixture supposedly. So you would say that this is a physical change. But if you see that they undergo they undergo a reaction where they collide with each other, and old bonds are broken down and new bonds are formed. So a new product is formed basically as a result. This means that a chemical change has taken place. Okay. So it depends completely upon the product which is formed as a result.
How will we know if it's exothermic or endothermic?
How will you know whether it is exothermic or endothermic? For instance, if you look into this question, they will not give you any such question which is where they are not going to mention anything within the context of the question. For instance, if you look into this question, nobody knows, or supposingly you haven't studied about anything regarding any particular reaction, okay, or regarding for instance here in this case scenario, they say that calcium carbonate undergoes thermal decomposition. Okay, you don't know anything with that, whether what products are, or supposingly I say there is a group 2 nitrate. Okay, it is a group 2 nitrate. For instance, it could be barium nitrate, it could be strontium nitrate, anything. They are going to mention this in the statement that it is being heated strongly. As a result, new product is produced, okay, as compared to the reactant. Okay, this type of change, when it says it is heated strongly, this means that it is undergoing some kind of decomposition. Heat is being provided to that reactant to produce a new product. Okay. So when this type of change takes place, now you know that this is a chemical change, right? Because a new product is formed, new bonds they're formed as a result. And this phrase here, heated strongly, it is heated strongly. This phrase basically determines that this reaction is going to be an endothermic. This is basically going to be an endothermic change, or it is an endothermic process, you can say. Okay. Is this point clear so far?
Yes.
Okay. Now, what is your answer for the next one? Okay, so Ayan Mayor says B. Okay, all of you are saying B. The reaction is endothermic. Yes, that's right. Reactants, why do we say that this reaction profile diagram is for endothermic reaction? Because the reactants, they have less energy as compared to the products. This means more heat energy is given in as compared to it is taken out, okay, or it is released when new products are formed. Also, the EEA is greater here. The delta H is, or the enthalpy change is an upward going arrow, which means that the enthalpy change is a positive change. Okay. So we say that this particular reaction is, as a result, it is endothermic. And the arrow which is upward going, but till the top hump or the transition state is going to be your activation energy, right? So the correct answer here so far is going to be option B. Good. Moving on to the next one.
Miss, why can't the option be A?
The reaction rate increases during the reaction. How are you able to determine by looking at this graphical representation regarding the rate of the reaction? Tell me.
We cannot.
No, I'm asking you, no, how can you determine the rate of the reaction by looking at this graphical representation? Look, on the y-axis, you have energies of the reactants and the product. On the x-axis, it represents the progress of the reaction, okay? When there is no such thing mentioned on both of these axes, neither you're able to determine the rate of the reaction by this energy curve, okay? How will you be able to determine the rate of reaction? The rate of the reaction is either determined by the gradient of the curve, okay? But that gradient of the curve must show change in y, that is the change in the amount of the product or the change in the loss of the reactants, okay? divided by the time taken, or whatever time change is for the progress of the reaction to take place. Okay, that is going to determine your rate of reaction. This is one method how you can find out the rate of reaction, by using the graph. Okay, or in other case scenario, it could be a rate time graph. Okay, as the time progresses, they are going to tell you how the rate is varying, or how the rate changes as the time progresses. Okay, no such thing is present within this reaction profile diagram, either on the y-axis, neither on the x-axis. Okay, to determine or to depict anything regarding the rate of reaction. Are you clear?
Yes, miss.
Okay. Then when you move on to the next question, it says that the reaction pathway diagram for a reaction is shown to you. Which statements they are correct? The reaction is exo or endo. Obviously, one of the two statements must be correct. The temperature of the surroundings, it is going to increase or is it going to decrease? Okay, Zoya says D, and Ayan, you are also saying D. That is 2 and 4. The reaction is endothermic. That's right. The reactants have less energy as compared to the products, and the temperature of the surroundings is going to decrease. Very good. Okay. Good, Ryan. Okay, so this means that option D is the correct one here so far. Okay. When you see that option 1 is absolutely incorrect, this means that neither your options A or B could be correct. Then you're going to look into 2 or 3. You know that option 2 is statement 2 is right, but then you're going to also correlate this with the temperature of the surroundings. In exothermic reaction, the container feels hot, which means that the temperature of the surroundings increase, and in endothermic reactions, it's the feels cooler. Which change of state is an exothermic process? So is it condensation, evaporation, melting, or sublimation? Ryan, tell me, why do you think A is the correct answer here so far?
A is the right answer because it gives out heat to the surrounding.
It gives heat?
Yeah.
To the
Surroundings.
surroundings. And what process is this?
Exothermic.
This is an exothermic process. Yes, you're right. But what is the change of state?
Oh, change of state is from, what's it called? Gas to liquid. It's bond forming.
Yes, very good. From gas to liquid. You can say that the intermolecular forces of attraction, they get stronger here. Okay. All right. That's nice. That's good. Okay. Moving on to the next one. Which row describes the change that take place in an endothermic reaction?
Miss, does it mean temperature of the surroundings or temperature of the object?
Temperature of the surroundings.
Miss, if there's an endothermic reaction happening and they ask us what's the like temperature of the solution, for example, so is the temperature increased or decreased?
Of the solution?
Yeah.
What do you think?
I don't know, because it's taking energy from the surroundings, so the surroundings are more cooler.
But that energy is basically being utilized to be given into the reactants, to be given into the bonds. Okay. So generally we say that the temperature is going to decrease.
The temperature won't stay the same.
It is being utilized in the bonds. It is being utilized in the bonds. Okay. You can think of this like, for instance, in exothermic reactions. Okay, what happens if even if the temperature, the thermometer you have placed, it is placed within the reaction mixture, supposing. Okay, the thermometer is placed within the reaction mixture, and one particular substance, basically, supposingly, I say that an experiment is conducted and a gas is burned. Okay, and this basically has methane in it, and it undergoes combustion, and whatever the temperature is going to increase, that temperature it will be increased for this water. Okay, whatever this temperature is increased, that will be recorded by this thermometer. Okay, yes, and this burning process is basically an exothermic process, so it is going to provide heat energy. As a result, this heat energy will be recorded by the thermometer. Okay, so we say in exothermic reactions the temperature generally increases, and in endothermic reactions the temperature generally decreases. Okay, also, if you there are two different ways of analyzing the things. Okay, this is one example in this case scenario. Okay, the second case scenario could be, maybe this is how you are asking. If you say that the container is having a particular reaction, and this is an exothermic reaction. Okay, this means heat energy is being transferred from the system into the surroundings. Okay, so obviously the temperature of the surroundings is different and the temperature of the system is different. Okay, the temperature of the surrounding increases because of the heat energy which is being transferred from the system into the surroundings, and the temperature of the reaction mixture tends to decrease. Okay, this is exothermic case scenario. But when this whole reaction, supposing another reaction takes place, and in this particular reaction, the heat energy is taken in. Okay, and it is utilized to break the bonds. All right, this means that the temperature of the surroundings and the temperature of the system, both of them, they are different. Right, the temperature of the reaction mixture tends to increase and the temperature of the surroundings tends to decrease. Okay, this is the endothermic process. I've told you both of the ways. I hope things are clear to you by far. Do you have any further queries?
So if they ask us, like, in the solution, is the temperature increased or decreased? So I have to say increase.
For which process? Exothermic process or endothermic process?
Endothermic.
For endothermic process, you will say within the solution the temperature increases, and for the surrounding the temperature is going to decrease.
Okay, nice. Thank you.
Okay. And what about this one here? Yes, this is right. Energy is taken in from the surroundings, which means that that the temperature is going to decrease. Your container feels cooler. Okay, so your option C is going to be the correct one here so far. Moving on to the next one. Okay, I am, yeah. Look at this one here. This is bond energy calculations. Is this clear? Is this clearly visible to all of you?
Yes.
Okay. The equation for the complete combustion of ethine. Ethine is C2H2. Okay. It is shown to you, and the reaction is given. These formula that you see is referred to as displayed formula. Okay. The bond energies, they are given to you, and you are asked to find out the enthalpy change of the reaction, which means that you have to find out the delta H of reaction when 1 mole of ethine is completely burned. Okay, tell me your answers. I will give you some time to solve. Write your answers in the chat box.
Miss, could you move the text box away from the question?
Yeah.
Miss, for does the 2 go on every single bond or only on hydrogen?
Which two?
2H single bond C triple bond C single bond H. Does it go on the whole thing?
Yes.
Okay, thank you.
This means it is basically 2 moles of C2H2 or 2 moles of ethine. They undergo complete combustion where they react with 5 moles of oxygen to produce 4 moles of carbon dioxide and 2 moles of water. Zoya, recheck your answer. Okay, Hamdan says B. What about the rest? Rayan is also saying A. Anybody else who has solved? Ahmad, Ibrahim, Basit, Ayan, Aida, Misha. What did you do here, Rayan?
So first of all, I added up the reactants, and then I added up the products, and I did reactants minus products.
In minus out, right?
Yeah.
Okay. So for in, you basically used how many bonds are broken down? How many C triple bond C?
1, 2.
2?
Yes.
Okay, 2. So this means that the bond energy is going to be 837 times 2. Then how many carbon hydrogen single bonds are there?
4.
4. Okay. So we use 4 here. This means that 415 times 4. Then how many oxygen double bonds? 5. So we're going to multiply this by 5. Okay. I think this is all what you have in the reactant side, nothing else, right? So you're going to add up all of this. What is the answer? 837 times 2 plus 415 times 4 plus 498 times 5.
5824.
5824. Okay. Now for the next one, for the energies which are given out, okay, when new bonds are formed. So bond formation releases heat energy, right? So carbon oxygen double bonds, how many double bonds do we have?
4.
How?
8.
8. In one molecule, you have 2 carbon oxygen double bonds. So in four moles, you would have 4 times 2, that would make it a total of 8 double bonds. Okay. Then oxygen hydrogen bonds, how many are there in total?
4.
4. Okay. So you're going to multiply this by 4. So the answer for the energies which are given out is going to be 805 times 8 plus 464 times 4. What is it?
8296.
8296. Okay. Now, this is the energy which is given in. This is the energy which is given out. What is the difference? 5824 minus 8296 is
Negative 2472.
negative 2472. Now, most of the students, they will think that maybe this is the answer. Okay. But they've clearly mentioned and make it bold that 1 mole of ethyne is completely burned. Okay. Is this 1 mole of ethyne? No. This is 2 moles of ethyne. You have to divide this by 2. What is the answer?
Negative 1236.
1236. This means your answer should be B, not A. Clear?
Yes.
Okay. Moving on to the next one. Look at this one here. Ethene gas C2H4 is completely burned in excess of oxygen to form carbon dioxide and water. The reaction for this exothermic reaction is shown. Okay. What is the total energy change in this reaction? Since they've already mentioned that this reaction is exothermic in nature, and even if they wouldn't have supposedly mentioned this, but they have mentioned that it burns in excess of oxygen, this means it is undergoing combustion, which should come to your mind as a reflex that this particular reaction has to be exothermic, which means that the delta H has to be negative. Okay. However, since they have already mentioned that this is an exothermic reaction, so they have given you options where all of them, they are negative values. Now you have to find out the total energy change in this reaction. Tell me your final answers. I'll wait. Yes, good, Joya. C is the right answer here. What did you do?
I first, I took the C double bond C, which is 614,
Hmm.
and then CH, there's 4 of them. So I multiply that by 4.
Carbon hydrogen bonds are
Multiply by 4, yeah.
4.
Yeah, and then for O double bond O, I
Mhm.
multiply that by 3.
Right. So this
So
is all the energy which is given in to break these bonds.
the total is 3751.
3751. That's right. Okay. Then the next one.
Then for out, I did 4 times 799
4 times 799.
and 4 times 467.
Yes, very good. So since there are two moles of water, this means that in one water molecule there is two oxygen hydrogen single bond, single covalent bond. So total of four bonds are basically present. This is the energy which is given out. Whatever the answer comes up, you will place it is in the formula, that is delta H is equals to in minus out, and then you will get the final answer. Okay. Here your correct answer is option C, that is negative 1313 kilojoules per mole, the total energy change for this particular reaction. Okay. Let me see if there is any question which must be discussed. What is the answer to question number 16? Which statement about endothermic and exothermic reactions is correct? Yes, E is the right answer. The reactants, they basically have higher energies on the reaction profile diagram as compared to the products. Okay. Then if you look into the next one, the equation for the reaction between gaseous hydrogen and gaseous iodine to form gaseous hydrogen iodide is shown to you. The reaction is exothermic. Which statement explains why this reaction is exo? The bond energies of the reactants, they're larger than the bond energies of the products. What does this statement mean? How have you perceived it?
Unless I thought D said
Okay.
more energy is released when two high HI bonds are broken. That's why I picked B because I didn't know any other answer.
Yeah. More energy is basically released when two hydrogen iodide bonds they are formed. Then the energy which is taken in when the reactant bonds they are broken down. Okay. So the correct answer here is going to be option B. But even if supposing you look into the rest of them, if it is exo products, they will have less energy level as compared to the reactants, which is why option C is incorrect. Energy is released when hydrogen and iodide bonds are broken. No, when reactant bonds are broken down, energy is taken in. It is absorbed, not released. Okay. The bond energies of the reactants are larger than the bond energies of the products. What does this statement mean?
It means that the energy in is greater than the energy out.
Yes, it means that the energy which is taken in is basically greater than the bond energies for the products, which is will be formed as in when new bonds are formed, okay, or when product bonds are basically formed. So this is again incorrect, okay. Less energy in exothermic reactions, energy which is taken in or the bond energies of the reactants is less as compared to the bond energies of the products, okay. So this is again an incorrect statement. Okay.
Miss, for the above question 16, I didn't understand B.
Option B. In an endothermic reaction, the activation energy is always higher than in an exothermic reaction. So they're basically saying that the activation energy in an endothermic is this option is, but they said that always higher than in an exothermic reaction. Okay, this means that they are putting a possibility, or they're basically putting up a case scenario that in endothermic reactions, the activation energy always has to be higher than as compared to in exothermic reactions. Okay. I will look into this option and then I will let you know. But this option is absolute. This is not correct. Maybe because of this always that they have put. Okay, this is giving you a complete perception of and developing a new dimension for endothermic and exothermic reactions. Okay, but I will look into this and then I will let you know. Okay, Zoya.
Okay, miss.
All right. Okay, moving on to the next one. Ethene can undergo complete combustion as shown below. The energy change of the reaction is given to you. Now the next dimension, as I told you earlier, that when we were doing bond energy calculations, that there are two different case scenarios how the question can be asked. Either they will give you the bond energies of all the bonds and they will ask you what is delta H. Here, in the second case scenario was that the delta H value for this reaction will be given to you and they are going to ask you what is the bond energy. Okay, so here they've asked you what is the bond energy of carbon oxygen double bond in carbon dioxide. Tell me the answer for this one.
Miss, can you show the options?
The options, they're not visible.
Oh, miss, never mind.
Yes. What are your answers for this one?
Ma'am,
Option
option C.
826 kilojoules per mole. Yes, that's right. What did you do here?
Okay, so first I calculated the energy
Hmm.
in the reactants.
Hmm.
So 4 times CH bonds and then
Hmm.
plus C bond and then plus 3 multiplied by OO bond, which is the oxygen bonds. Then I got the
Hmm.
answer 3748. So we know the energy change. So I did 3748 minus X, which is gonna
Hmm.
be the energy of the products is equal to negative 1408. So I moved the products on the other side and I got the answer 1048, negative 1048, negative 3748. So I got minus 2340. So minus would be cut. So 2340 I subtracted it with 2 multiplied bulky 4 multiplied by 463, which is HOH bonds.
Hmm.
So answer was, yeah, answer I negative 4 into 463 and then I got 4192. And now I know that there are 4 CO bonds, so I just divided it by 4 and then I got 826.
826. Okay.
Yes.
Yes, that's the right method. Basically, what you're going to do here is that when you know the value for delta H here, okay, you're going to place this value here, which is 1408. Okay. You will find out the energies which are given in and simply place X wherever the bond energy for carbon oxygen double bond lies. Okay. And for you're going to then find out the value for X using simple arithmetics. Okay, and that is how you're going to solve the whole question. As a result, you get this answer. Is anyone there present in the class who is not able to get this question? Has everyone got the explanation?
Miss, I just have a question.
Yeah, Ryan.
So first of all, you would find all the bond energy for the reactants, the in, and then would you only find 2H2O in the out?
For the out, you're going to write two. There is how many bonds there are? 4 times oxygen hydrogen. So
Yeah.
what is the value for oxygen hydrogen? That is going to be 463, right?
Yes.
Plus how many bonds for four? There are 4 bonds of carbon double bond oxygen. Either you can write carbon double bond oxygen simply, or you can simply replace this with X. Okay.
Oh,
And then find the value for X. This value for X is basically your carbon double bond oxygen bond energy. Okay. Which is going to be 826 kilojoules per mole. All right.
all right.
Okay. This is it for today's session. Also, this last question, Zoya, yeah. So this particular statement that you are asking is basically what I was explaining, that the activation energy is always higher than in the exothermic reactions. The activation energy basically is dependent upon the energy from the reactants to the transition state. Okay. It is not dependent upon the enthalpy change of the reaction. Okay. So which is why by just looking at the whether the reaction by just by looking at the difference of the energies between the reactants and the products, we cannot determine the activation energy. Okay. Which is why we choose, and since your MCQ paper basically is also best choice, right? So the best choice here is going to be option D, which is why we nullify option B here. Is this point clear? So activation energy is basically the energy which is required by the reactants to be reached till the transition state, okay? And is not dependent upon the energy which is present between the relative energies of the reactants and the product. Is this point clear?
Yes. Miss, I have one more question before you go.
Yes.
For the last one that we solved, I got the same answer but in negative. Is that right or wrong?
No. Why did you got the answer? What do you mean if you got the answer in negative?
I got
How?
negative 826.
How? There must be some calculation mistakes. If you have done it in a paper, just send it to me on WhatsApp. I'll check.
Okay.
In the next class, inshallah, your next session will be next week, right? On Monday. So we will start with the rate of reaction and we will we'll pace up now. Okay. So in the next class, we'll look into rate of reaction and your reversible reactions and equilibria. And for your Thursday's quiz, that is tomorrow, you will have everything till chemical energetics. Okay. Any questions so far? Is everything clear?
Yes, sir.
Okay. Take care. Allah Hafiz. Thank you. Bye bye.
Allah Hafiz. Thank you.
Allah Hafiz.
Allah Hafiz.
That's it.
Allah Hafiz. Allah Hafiz.